Welcome back. In part 2, we will look at the most common application areas for rendered AI both in and out of automotive. How in the context of next-generation systems engineering do you do A-B comparisons? Whose radar are you going to integrate into the car when what you care about is not the bandwidth or the noise figure of the radar, but what you really care about are the AI outcomes that will be driven by the new sensor. Sensors are the lifeblood of AI. It is one thing to take an existing system into the field and gather data. It is quite another problem to evaluate a component in the middle of a 5-year development cycle. I mentioned the rare events and edge cases and how we help mitigate risk. However, humans are infinitely inventive and the world moves on. Both forces create new edge cases. We will never be finished with rare events. It is the very nature of change. The way we have built our tool helps drive a process by which we can deal with unexpected but possible phenomena. In our workflow, one of the outcomes is not just how good is our model, it is about how well does it generalize. If you train on a certain set of domains, you want to be able to build another data set where you also know the ground truth to understand if your model is capable of generalizing between those two. This is where what-if scenarios and experiments become important. And finally, active learning is the recombination and automation of these tools in new ways to solve emerging problems in autonomy. By way of example, if you have sensors at the edge where algorithms are running, how do you keep them up to date? How do you identify problems? How do you communicate enough data back that you can address the confusion without spending the time and experiencing the latency of massive data collection efforts? In a concept, we are sending back metadata, not the full imagery, but metadata to dramatically decrease the bandwidth requirements. The data sets then can be reconstructed synthetically via simulation.